Hi there. Today we're going to look at the Backhauler USB. This cool little board is made by Allied Component Works, and I found it on Tindy. You ever wanted to connect your SPI sensor to your computer? Well, the best way to do that is with a Silicon Labs SPI to USB bridge. Now that's this tiny little chip back here, but if you just want to prototype it, how are you going to use a surface mount chip? Well, there's this great eval board called the Backhauler USB, and again I found it on Tindy. So this little prototype board lets you connect your SPI sensor, your SPI LCD, anything that wants to communicate with SPI, and connects it right to your PC through USB. And I'm going to show you how that works. Okay, so let's first talk about hooking up this prototype board. You can see all the relevant symbols from the Silicon Labs chip are broken out onto this board. Now I've put a header in it so I can easily prototype it, but there's plenty of prototype space on this board and you can do anything you want with it. So each of these things is relative to SPI. You got the clock, you got the two data lines, you got chip selects. The chip even provides a 3.4 volt output, and the board brings in the USB 5 volts as well. So you got plenty of power to test your sensors with. Now I've connected that over to my proto board, and I'm using a voltage, an isolated voltage supply, or voltage measurement chip, just as a sample here. Now from the data sheet on this voltmeter module, I've connected the right lines to the SPI to USB backhauler, and on the other side we'll see is my voltage input for the sensor. We'll play with that a little bit later. So that's all it was. It took me about 5 minutes or less to solder the header on this board and connect it to whatever I want on my proto board. Now we have to get the software from Silicon Labs, and that's very easy to download and install on your Windows PC. It is a Windows piece of software. All the websites are available that came with this board, so it's super easy to get everything I needed. So if we need to know a little bit about the sensor and how it communicates, whatever we're talking to. So whatever data sheet you have on your sensor, you need to know how it communicates in some of the settings. So let's go look at the interface that Silicon Labs offers for this prototyping this chip. So this is what the eval tool looks like when you bring it up on your computer. It's a little bit hard to see, but I'm going to zoom in and see if I can show you the different sections. Basically, you hook your USB cable up to your computer, and it recognizes the chip once you've installed the drivers that came with the Silicon Labs software. So basically, I'm going to go over here and just hit connect. Okay, and it's actually connected right to that chip that I've plugged into my computer. There's a bunch of different sections on this, but I'm just going to show you the basics for this interface. Basically, you have to tell it, based on your sensor, how many bytes you want to send and receive, and then you have to tell it something about the SPI bus. In this case, this voltmeter runs about 400 kilohertz on the clock cycle, so that's what I want to set it to. There's lots of options on this clock setting, so you can see up to 12 megahertz for this chip. But again, we're going to use 375 for this chip. So just as a quick example, we can set the transfer rate to write and then read, and it will send a message out on the SPI bus and then read what you get back. For this situation, I've set up the chip select on chip select 0, so there are 10 chips selects you can use, so you could actually talk to 10 different sensors or 10 different things with this backhauler at the same time. You just set the different chip selects. So I'm going to send out a message to this voltmeter, 2 bytes, A100, and this is going to actually read back the temperature that's in this module. In addition to the voltmeter, it also reads back temperature. So I'm going to say execute. Okay, and then I got an FF, which is no data, and then you see I get this number back 012E. Now this is hexadecimal, and it basically translates by the data sheet into the current temperature in degrees Celsius. So I'll need to translate that, but I've successfully communicated with my device. Now we're going to try another command. A000 for this device is actually the voltage reading. And again, the first data that comes back is the last information about the temperature, and I'll do it again, and I'm seeing a 0 volt reading. So just to show you that I'm going to get a voltage reading, I've connected the 3.4 volt bus over to the reading side of this voltmeter. And now we'll go back and look at the data we get back from the SPI bus. Okay, so now that we have that voltage connected, we're going to send another message. And again, the first time you get the same data back you got the last time. But then we're going to get this reading 0D44, which in hexadecimal is 3,396 or 3.396 millivolts. So we can see that we've gotten the 4 volts or the 3.4 volt bus connected. So that's just a quick and dirty example of to show that we're communicating between the USB and the SPI module. Now Silicon Labs has all kinds of C modules and DLLs, so you can integrate this connection into your own program and pretty much communicate any way you want to with a SPI sensor or piece of hardware. So there you go. That's a quick look at the Backhauler USB. Again, this board is a simple board for prototyping the Silicon Labs USB to SPI Bridge, and you can pick it up on Tindy. It's made by a company called Allied Component Works. Again, I was using it with the Allied Component Works voltmeter module, which I'll talk about a little bit more in another video. That has its own unique coolness to it. But there you go. If you want to use a SPI sensor, a SPI LCD display, anything you want to communicate with SPI directly to your computer, this is a quick and easy way to prototype it and get it all working before you look at making your own board with that surface mount chip on it.